Hello everyone, I'm Ashraf. Welcome to A Square again. I'm here with a few important tricks in trigonometry, which is useful for all the levels to learn trigonometry. You know, what are the important angles for which we remember the values of sine, cos and tan? They are 0, 30, 45 degrees, 60 degrees and 90 degrees and multiples of 90 also. We can find or we can memorize all the values of sine, cos and tan using our hand. I will explain this trick. See my hand. We call this finger 0 degrees. 0, 30, 45, 60 and 90. In order 0, 30, 45, 60 and 90. These are the most important values in the acute up to right angle. Now, if we want to find the values of sine, this is sine 0. To find sine 0, we have a trick. We have a square root, which is to be memorized. A square root, and inside the square root there is a fraction. So for this fraction, denominator is default, it is 4. So square root of something which is unknown divided by 4. What is this unknown? That unknown will be filled using these fingers. See, for sine 0, you know that this is 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So for sine 0, we see how many fingers are there above this 0. 0 finger. So we fill 0 there. So we can see root of 0 over 4, which is 0. So sine 0 is 0. This is for 30 degrees. Above 30 degree, only one finger is there. So we fill by 1. So it is square root of 1 over 4. Square root of 1 is 1. Square root of 4 is 2. It's 1 over 2. If you want this one, what is this? 45 degrees. For 45 degrees, how many fingers are there above this? There are 2 fingers. So square root of 2 over 4. That is square root 2 over square root 4, which is square root 4 is 2. So we can write square root 2 over 2. That's the value of sine 45. Then this is 60 degrees. Sine 60. How many fingers? 3 fingers above. Fill by 3. So you get square root of 3 over 4. Square root of 3 over square root of 4. Or square root of 3 over 2. Then this is 90 degrees. For 90 degrees, above 90 degrees, there are 4 fingers. So we'll fill by 4. So it is 4 by 4. 4 over 4, which is 1. Square root of 1 is 1. So sine 90 is 1. Sine 0. Above this finger, 0 fingers. So 0 by 4 inside square root. That is 0. Above this one, there is only 1. So sine 30 is square root of 1 over 4, which is 1 by 2. Sine 45 is square root of 2 over 4, which is square root 2 over 2. Above this, 3 fingers. So square root of 3 over 4, which is root 3 over 2. This one above this, there are 4 fingers. So 4 over 4, which is 1. Square root of 1 is 1. If you want cos, we can use the same. The values of cos also we can use the same. But the fingers we count below that. The angles are the same. 0, 30, 45, 60 and 90. So for cos 0, how many fingers are there below this one? This is 0, you know. So below this one there are 4 fingers. So we can take 4 and put there. So cos 0 is equal to square root of 4 over 4. That is square root of 1, which is 1. Then you know that this is 30 degrees. For cos 30, how many fingers below this we count and enter the 3. So 3 over 4, root 3 over 2. This is 45 degrees. Cos 45 is, there are 2 fingers below. So 2 over 4, root 2 over 2. For this one, this is 60 degrees. For cos 60, we count the fingers below this. It's 1. So 1 over 4. Square root of 1 over 4, which is 1 over 2. Then for this one, finally 90 degrees. For cos 90, how many fingers below this? 0 finger. So 0 over any number is 0. This is how we find the values of sine and cos using my fingers. We can find tan also using this. The same angles will be given for fingers: 0, 30, 45, 60 and 90. For tan 0, above this no, so we put 0. Below this 4, so 0 by 4. For tan, the numerator will be how many fingers above this. The denominator will be how many fingers below this. So it is 0 by 4, which is 0. Let's see tan 30. So it will be square root of something over something. That numerator is how many fingers above? It's 1. The denominator is how many fingers below that? That is 3. So 1 over 3 in the square root, you get 1 over root 3. If you want tan 45, it is above number and below number, so it is 2 over 2, which is 1. Then for this one, 60, tan 60, 3 over 1 inside square root, you get root 3. Then for 90, you get 4 over how many fingers below? 0. 4 over 0 is not defined. Any number divided by 0 is not defined. This is how we find the values of sine, cos, tan for these important angles. What are the other important angles we usually memorize? They are the multiples of 90. Multiples of 90 are 0, which is 90 times 0. 90 times 1, then 90 times 2 is 180, then 270, 360, then 450, 540, etc. We can take the numbers before 0 also, which are negative 90, negative 180, negative 270, negative 360, etc. How to find the values of sine, cos, tan for these multiples of 90? Let's start from 0. So we write the values of sine: 0, 1, 0, minus 1, 0, 1, 0, minus 1, etc. That means sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, it goes on. Left hand side also, for negative values also, it is going on in the same pattern. What about cos? For cos also, the numbers are same, but it's shifted. That means below 0 we have to put 1. So cos 0 is 1. Then in the same way we will write the numbers: 0, minus 1, 0, 1, 0, minus 1, and goes on. For tan, we just divide these two. What about tan 0? 0 over 1, which is 0. Tan 90, 1 over 0, which is not defined. It goes on in the same way. In this way, we can find all the values of sine, cos, tan for the degrees, which are multiples of 90 degrees. The next interesting topic is hexagonometry. Using a hexagon, we can memorize many rules in trigonometry. The relations between sine, cos, tan, cosec, sec, cot. See, this is a hexagon. We mark all the corners, all the vertices with all the 6 trigonometric names. We need to memorize only one thing. Tan is equal to sine over cos. So we put tan on the left, then sine and cos. So tan is equal to sine over cos. Then against each one, for the diagonal, at the other end of the diagonal, for tan we write its reciprocal, which is cot. Other part of sine diagonal we write cosec. The other part of cos diagonal we write sec. We can see that on the right side, all from C will be there. All the trigonometric ratios starting with C will be on the right side. Now take all the triplets. As I told, tan, sine, cos. So the first one will be always equal to second over third. Tan is equal to sine over cos. If you take the next one, you can see sine, cos and cot. So sine is equal to cos over cot. All the 3 ratios, this relation is valid. What's the relation? When you consider 3 consecutive ratios on this hexagon, the first one will be always the second one divided by third. Interestingly, if you go the other way around, that is anti-clockwise, also we will be getting the same relation. For example, the first one, tan, sine and cos. So you can say that cos is equal to sine over tan. In the same way, any 3 consecutive 3 will have the same relation. See the diagonally opposite trigonometric ratios. What is opposite to tan? It is cot. So we can make a relation. Put 1 in the middle. Tan times cot is equal to 1. Then sine times cosec is equal to 1. Sec times cos is equal to 1. When you multiply diagonally, will get you the result 1. There are horizontal relations also. On the top horizontal, you can see sine and cos. What is the relation? These are complementary relations. Sine theta is equal to cos 90 minus theta. Tan theta is equal to cot 90 minus theta. Reversely also, cot theta is equal to tan 90 minus theta. Sec theta is equal to cosec 90 minus theta. Cosec theta is equal to sec 90 minus theta. These are horizontal relations from this hexagon. That means if you learn this hexagon, you learn most of the trigonometric relations. You know the Pythagorean relations of trigonometry. Take the upper triangle. What are there on the upper triangle? You can see sine, then cos and 1 also. The relation is sine square theta plus cos square theta is equal to 1. There are 2 more triangles to be taken like this. From the other triangle, you go clockwise. So in the second triangle, 1 plus cot square theta is equal to cosec square theta. Clockwise. Again see, the left side there is 1 more triangle. In that, tan square theta plus 1 is equal to sec square theta. So these trigonometric relations also evident from this hexagon. I hope this will be very useful to learn the values and relations of trigonometry. Thank you so much.